field. So you can say that if the charge particle will move in the combined electric and the magnetic field, then you can say that there will be the electric force also on the charge particle and the magnetic field, magnetic force on the also on the charge particle. Okay. So
Yes,
you
sir.
can write, and force is a vector quantity. So you can write the total force on the charge particle. This is the total force on the charge particle. It is equal to the vector summation of the electric force on the charge particle and the magnetic force on the charge particle. This electric force is given by charge into electric field.
Yes, sir.
And magnetic force on the charge particle, we have already discussed, is given by Q, velocity of the charge particle, and the magnetic field. So
Yes,
when you
sir.
will put both the values here, you will get the total force, that is Q into E plus Q into V cross. So this is the total force of the charge.
So you can see, sir, I have sent you the question paper.
Okay, you
I
can
have
send
sent you
me.
the.
You have sent
I
me
have sent you.
on my number.
Yeah, on WhatsApp. Did you get it?
Okay, so we will discuss this when we will have a time. Okay. No problem. So see, this is the total magnetic force on the charge particle. So simply you can say that when the charge particle will move in the combined electric and magnetic field, two types of force will be there: electric force and the magnetic force. Electric force is given by charge into electric field, and magnetic force is given by charge into cross product of velocity and the magnetic. Write down this, then we will discuss.
Done, sir.
Now I am taking one question on this.
Yes, sir. Sir, I just had one request, sir.
Okay. What?
Sir, actually, I have to go out today, sir. So can you just leave me at 8:30?
Okay, no problem. It's fine.
Thank you, sir.
And we will discuss your paper. Are you available tomorrow?
Tomorrow, yeah, I should be available.
If you are available tomorrow,
So
then
I'm available tomorrow and Saturday. Saturday also I'm available.
Saturday. Actually, Saturday I am having so many classes. So Okay, so
So like just 15 minutes, sir. That's it, because it's small paper, 10 questions.
you are right, but I have to tell you the question papers in detail. Okay. So,
Okay.
because in
Yeah.
15 minutes I will tell you, but you will not get it.
No, it's like three. There were three derivations. Like that
Yeah.
was straight and all. Three multiple choice, and then two numericals.
Okay, so maybe I will discuss your paper in the next class, because this chapter will be finished in 2 lectures, I think. Not in 2 lectures.
So no, you sir, you can discuss tomorrow also. It's fine. Just you can just message me the
Okay,
time. I'll be
if
here.
I will be available tomorrow, then I will message you on WhatsApp.
Yes.
Okay,
Okay.
then we
Okay.
will discuss. Okay.
Done, sir.
So now I am taking this question. Do you know how to calculate the cross product of two
Yes,
vectors?
sir. Yes. Yes, sir.
So this question is based on the
Another
cross
cross
product.
product.
To see this question, in this question, a charge Q is equal to 2 coulomb is moving in a region have electric field in the this electric field is given in the vector form, and the magnetic field, this magnetic field is given in the vector form with velocity, and velocity is also given in the vector form. They are saying calculate Lorentz force, and what is the formula of the Lorentz force? F is equal
F
to,
is equal to QE plus Q into V into B.
yeah, plus Q into V cross. So first we will calculate this V cross V,
Yes, sir.
and for the cross product, what you should do, make the brackets like this. This is known as determinant. This is
Okay.
I cap, here write J cap, here write K cap.
K cap.
Okay. And now here first vector is B vector. So write the coefficient of I cap for the vector B vector. So this is B vector. What is the
Yes,
coefficient
sir.
of I cap? 1.
1.
Coefficient of J cap is -3.
3. Yeah, minus 3. Sorry.
Coefficient of K cap, there is no K cap, so
There
the
is no
coefficient of 0.
0, sir.
Now for this magnetic field, write the coefficient of I cap, J cap, and K cap. I cap is 1, means coefficient of I cap is 1 here. Coefficient of J cap is 2. Coefficient of K cap is 5. So can you calculate this by yourself, or should I tell you? If you are
Sir, can
comfortable
you,
in,
sir? Yes, I can solve this one.
okay, okay, no
I'll
problem.
solve the next one, sir.
Okay, no problem. So here what you have to do, first write this I cap. First write this I cap and bracket. What you will do, you will hide this column and this row. This column and this row, you will have this thing. Okay.
Yes, sir.
Now what you will do, you will cross multiply this with this minus this with this. So cross multiplication of 5 with -3. Right here, 5 into -3. This is the cross multiplication of 5 with -3, and right here after that minus sign, then cross multiply this 2 with 0. So this is for I cap. Now for J cap, you will write minus of J cap. So for J cap, hide this column and this row. This column and this row. So this column and this row, hide it. So you will have this 5 into 1.
5 into 1 and 1 into 0.
Very good. 5 into 1 minus 1 into 0. Now for K cap, again you will write here plus K cap.
Yeah, we'll hide the row.
Yeah, you will hide this row.
K cap row. So do 2 into 1 and 1 into -3.
2 into 1 minus of 3 into 1. Now we can calculate this. So we will get the answer. This will be I cap. This will be minus 15
Yes, sir.
because this will be 0 here. J cap will be 5 J cap. And K cap will be again 5 K cap. So this is C. This is 2. And this is minus minus plus minus minus plus 3. 2 plus 3, 5. This is 5 K cap. So finally you will have minus 15 I cap minus 5 J cap plus 5 K cap. This is your B cross B. Now this question is very easy. You have to put the value of B cross B in this equation, and all the values you can put in the equation number first. So this is, consider this as equation number first and put the values accordingly. Charge is 2 coulomb. Now electric field, put the value of electric field. I cap plus 2 J cap. So this will become I cap plus 2 J cap. Again this will become 2 and put the value of B cross B. This is minus 15 I cap minus 5 J cap plus 5 K cap. So this force, total force or the Lorentz force, you will get the answer minus 28 I cap minus 6 J cap plus 10 K cap. This vector addition you can do by yourself.
Yes, sir.
It's very easy. This is just the addition of I cap with I cap, J cap with J cap, K cap with K cap. So you will get this answer. Finally, you will get this answer. Just note down this.
Second scroll down. Done, sir.
Now, till now we have discussed that what will happen when a charged particle will be in the magnetic field, or when the charged particle will be in the electric and the magnetic field both. So now we will discuss that what will happen when a current carrying wire will be placed in the magnetic field. Will be placed in the magnetic field. We have discussed that when a charged particle is moving in the magnetic field, there will be the magnetic force on the charged particle given by F is equal to QVB sin theta. And now we will discuss for the conductor. So now see here. So this is your heading, force on a current carrying wire in magnetic field. See here, this is your wire, this is your wire, and this is the magnetic field. This wire is present in the magnetic field, and this wire makes an angle theta with the magnetic field, and L is the length of the wire, and current I is flowing through the cross section of the wire, and A represents the area of the cross section. All the things I have written here. A is the area of cross section of the wire, L is the length of the wire. Now this thing I will discuss later. See, this is the wire, and in this wire there is a current. Okay. So we know that inside the wire there are large number of free electrons. Okay, there are large number of free electrons. Means that those free electron will constitute the current in the wire. Means right now in this wire, there will be the electrons, and those electrons are moving in the opposite direction of the current with the drift velocity we have already discussed, with the drift velocity. Now I am assuming that there are the positively charged carrier in this wire, and the charge on those positively charged carrier will be equal to that of charge on electron. Okay, and
Yes, sir.
represented by E positive. So why I am doing this, you will get to know. So E positive represents the charge carrier moving in the direction of current. Okay, I have assumed that. And N represent the number of charge carrier per unit volume. Means in the unit volume of this conductor, small n number of the charge carriers are there. So we know that current carrying wire, in a current carrying wire, there are many charges inside are in motion. Okay, so many charges inside are in motion, and whenever a moving
Yes,
charge
sir.
is placed, so you can imagine this as in this wire, there are E positive charges. There are E positives moving in the direction of the current. Okay, whenever a moving charge is in the magnetic field, the charge will experience the magnetic field. We have discussed later. We have discussed earlier. Okay, whenever there will be a moving charge in the magnetic field, there will be some force on that charge. Now I am taking the small length of this wire. TL length I have taken. DL is the small length of the wire. So now see this DL length. So in this DL length also there will be the charge carrier E positives. So I am just calculating the force on one E positive. Okay, force on one E positive. And this E positive inside the conductor is moving in the direction of the magnetic field. So you can say that force on one E positive is equal to, what is the formula of the force? If a charge is moving in the magnetic field, 2 sine theta. The value of charge is E. Okay. And what is the drift velocity? What is the velocity with which this E positive is moving? Drift velocity, that is. This E positive is moving with the drift velocity and the magnetic field and sine theta. Now, in this DL region, see this capital N. Capital N is the number of E positive in DL region. In this DL region, the number of E positive is represented by capital N. So there are capital N number of charge carrier. So force on one charge carrier is this. Force on N number of charge carrier will be multiplication of N with this. Okay. So force on all E positive in elemental region. And in elemental region means this region, okay, is equal to N times of E into Vd into V into sine theta. Now calculate the volume of this DL region. So volume we can calculate easily. This is the area and this is DL. A here is represents the area of cross section and DL is the small length. So the volume will be area into small length. So now we will calculate total number of charge carrier in this volume, ADL volume. Okay, so you can write here in ADL volume, total number of electrons, not the electrons, you can say total number of E positive is equal to, what we will do for this now? First, we should know for this what is the total number of charge carrier in a unit volume. Okay, in a unit volume, there are a small n number of charge carriers. So see here, small n represents the number of charge carrier per unit volume. Means in a unit volume, there are n number of charge carrier. So in ADL volume, there will be n into ADL charge carrier. So you can say this is the capital N, total number of E positive in DL volume. So capital N value will be NA into DL. So now you can put the capital N here. You will get the total force in the DL region. So you can write force on all E positive in elemental region.
Yes, sir.
So you will put this value of N in this formula. So you will get NADL. Instead of this N, you have put this value. And you will have this E into drift velocity into V into sine theta. And I am writing here what is V suffix D. So V suffix D represents the drift velocity. So this region is very small. So force on this
Yes,
region
sir.
also will be small.
Be small.
Means DF, you can say DF will be, this term represent the DF. DF will be NADL E into V suffix D into V into sine theta. Now, if you want to calculate the, this DF is the force on this DL region. Now, if you want to calculate the total force on the wires, and then you have to integrate this equation. You have to integrate this equation. So you will integrate this. So this will become the total force on the wire. And here, out of the integration, you will take the constant term. So this small n is constant, area is constant, small e is constant, drift velocity is constant, magnetic field is constant, also the sine theta. And this is integration of dl. And integration of dl represent the length of the wire. So here you will have this form. This force is equal to ANEVT into V sine theta into L. So we know that the relation between the current and the drift velocity is I is equal to ANEVT. So instead of ANEVT, you can put the value of the current flowing in the wire, and you will have this V L into sine theta. So this
Yes,
is your
sir.
final formula. And if you want to write this formula in the vector form, so you can write F vector is equal to I L vector cross V vector. So in both the form, you should know the formula.
Yes, sir.
So you can say from this formula, as you can see here, this force is a cross product of length vector and the magnetic field vector. So you can say here this force on the wire due to the magnetic field will be perpendicular to the length of the wire, and also this force will be perpendicular to the magnetic field in which the wire is placed. So here what is F representing? F represents the total force, total magnetic force. Now note down this.
Yes, sir.
You want to go at 8:30?
Yeah, like in half an hour. So let's scroll down. So you can just scroll up for one line up, one line up. That's it. Thank you.
Have you done this derivation from your question paper? Force between two parallel current
Yes, sir.
carrying
Yes,
conductors.
yes, sir. Yes, sir.
So
F12 is equal to F21. We did that. We used I, L, B2 and sin theta. We used that.
So means this result of this derivation will be used, and next topic is the same topic. Force between
Yes,
the
sir.
two
Yes.
parallel conductors.
So for the second one, the multiple choice question, it is M1 V1 greater than M2 V2, right?
This question.
Second, the multiple choice one.
Okay, I'm just checking. Please note down. Okay.
Yes, sir.
This is very easy question. Yeah, I'm ready. So here, the radius of first complete this, then we will discuss properly.
Yes, yes, sir. Yes. You can scroll down. So little more up, sir. That. Yeah, that's it.
Fine.
Yeah, yeah.
Question is very simple, but you should know the formula of first the radius, where the charge particle is moving perpendicular to the magnetic field. Then you can solve this question. This result is very useful.
So you can scroll down.
Okay, please learn this both the results.
Yes, sir. Yes. Okay.
This is the force on a current carrying wire in magnetic field. This is a scalar form. This is a
Yes,
vector
sir.
form.
Vector form.
Both form you should know. And this thing also. This thing is also very important.
Done, sir.
Now we will discuss your question. Okay, so I'm discussing.
Sir, actually, I didn't remember the formula. That's why I'm asking you.
Okay, no problem. Actually, they are saying that two particles of same charge,
Yes, sir. Same charge.
same charge are projected to a region of perpendicular magnetic field. Perpendicular magnetic field means the motion of the charge or the velocity of the charge will be perpendicular to the magnetic
Perpendicular.
field.
Yes,
So
sir.
this is the magnetic field, and this is the velocity of the charge.
Yes, sir.
Both are perpendicular. So when the charge particle moves perpendicular to the magnetic field, you should know the whole story behind the question. Okay, so the charge particle will follow the circular path we have discussed.
Yes, sir.
So, and that
Yes.
radius of the circular path is given by mv divided by qb.
QB, yes.
Now, this formula you should know first thing. And
Okay.
after that, they are saying that radius of the circular path followed by the particle means for the first radius of the path 1 is greater than radius of the path 2.
Path 2.
Means this is the radius of the charged particle 1.
Yes, sir.
This is the
1.
radius of the circular path for the charged particle 2. So simply
2.
apply the formula here. Here is m1 v1.
Yes, sir.
q1 into v1 you can write, and
V1.
this will be greater than m2 v2. You can write this m2 v2 divided by q2 into
Q2 V2.
But here magnetic field is same, so you can write
Yes,
v1
sir.
by v2.
So it will be B.
Yeah, you can say this is b simply.
Yes.
And here they are also saying that the mass of the both the particle means m1 is equal to m2. Okay, both are same, mass is same.
Yes.
And
Yes, sir.
not the mass, they are saying the charge is same. Okay. Charge is same means q1 is equal to q2. Okay, and so here your this charge and this thing will be gone, and this v1
Yes, sir.
v1 will be gone. So your answer will be m1 v1 greater than m2.
So it's option C. Okay, it's correct. Sir, what about the third question in multiple choice?
Third question.
Yeah.
Okay, we
The
will
cell
discuss.
discharging.
Actually, I will tell you, but we do not have much time. Okay.
So can I just tell that one and that'll be fine. But that's it. Just that one, just that.
Okay.
Third one, that's it.
The terminal voltage across a secondary cell is equal to the EMF.
Yes.
This is very simple. See, this equation you should know. V is equal to E minus IR.
Yes, sir. Yeah, it's used in that derivation also. Parallel combination.
Now see. So they are saying the terminal voltage across a secondary cell is equal to its EMF. So this is the terminal voltage and this is the EMF.
Yes.
Okay. So they are saying this EMF means V is equal to E. Means the terminal voltage is equal to the EMF. So what will happen? So write the instead of this V, you will put the value E, and here is again E, and here is minus IR, and here is E minus E. Here is minus IR.
Minus IR.
So this is 0.
0 minus IR.
So your current will be 0.
Okay, so when no current is passing through the thing.
Okay.
Yeah. Okay. Correct, sir. Thank you, sir.
Charging and discharging, we cannot tell. Charging and discharging.
Yeah, I knew that it was not charging, discharging.
For charging, here will be plus.
Yeah.
For discharging, here will be minus. Okay,
minus.
I will discuss all the things. Don't worry about that. Okay, so just now, see here. If tomorrow we will have a class, then we will discuss. Okay, see here now. Force will be, and what is the formula for the force on a current carrying wire in the magnetic field? F is equal to I into magnetic field VL into
IVL sine theta.
Okay, so if this sine theta will be maximum, okay, then this force will be maximum because force is directly proportional to sine theta, and the maximum value of sine theta is at 90 degree. Okay, so at theta is equal to 90 degrees, sine 90 is 1. Sine 90 is 1. Simply put the value. Then you will put the value here sine 90. So this force will become IVL, and this is the maximum value of force on the wire for a given current, magnetic field, and the length of the wire. Now, the direction part. how you will find the direction of the force on this wire. So for that, you will use your right hand. Point your fingers along the direction of the current and curl your finger in the direction of the magnetic field or towards the magnetic field. Okay. So this is the direction of the current. See, this is the direction of the current and this is the magnetic field. So see, point your fingers along the direction of the current and curl it towards the magnetic field. So you will get
Yes, sir.
direction out of you, means inward direction of the
Outwards.
force.
Yeah.
Not
Yes,
the
sir.
outwards. You will get the inwards. If something is going away from you,
Away
means
from me.
inward. Yeah, inwards.
Yeah.
So that this direction of the force will be just add this in your notes also. Direction
Yes,
of the
sir.
force will be inwards. This is cross. And this direction is given by the right hand thumb rule. Point your four fingers in the direction of the current and curl towards the magnetic field. Thumb will give you the direction of the force. So for solving any question and any numerical part, you should know the proper formula and
Yes,
the
sir.
terms and you should know what are the terms in that formula. Like in the formula V is equal to E minus IR. If I don't know this equation, then how will I solve this the question? Have you completed this part?
No, sir. I have to do. So just a minute.
Okay, no problem. Just so, Harsh, at what time you are free tomorrow?
Sir, you can keep at the same time, sir.
At the same time.
Yeah. Like 7:30 for you.
So we will have only 1 hour class. Okay.
Yes.
Because I have to discuss the question paper and for the syllabus point of view also. 30 minutes we will discuss the question paper and 30 minutes. So you will point your fingers along the direction of the current
and curl the magnetic field.
towards the magnetic field.
Yeah,
You
thumb will
have
give
to,
direction of force.
yeah, and your thumb will give the direction of the force.
Done, sir.
So now I will discuss these two questions on the direction.
Okay.
Very simple question.
Yeah.
Means here is the magnetic field and this is the magnetic field. This magnetic field is inwards.
Yeah.
This magnetic field is inwards. Now we have to tell the direction of the force on this wire.
Yes, sir. I'll tell you. Yes, sir.
First, you should know. Just I am writing the formula in the vector form. This is given by L cross P. And so you can say the force vector will be perpendicular to the length vector.
Yes, sir.
And the force vector also will be the perpendicular to the magnetic field vector. So you will use this thing. So your force, see here, this thing. Your force will be perpendicular to the length of the conductor. Now you can solve. I am solving this part. You should solve this part. Okay.
Okay.
So what you will do for this? You will point
Put your
your
forefinger direction of the current, like this.
point your fingers in the direction
Yes.
of the current. And what is the direction of the magnetic field?
Inside, inwards. So you
Inwards.
rotate your hand inwards.
Yeah. So like this we will do. In this direction the current is there. Okay.
Yes, sir.
And the direction of the magnetic field is inwards. Inwards means something is away from me.
Yes, sir.
Okay. Something away from me.
Away from me.
Yeah. So I will do like this, and magnetic field is inwards. Inwards means something away from me, like this.
Yes, sir.
Okay. So the direction of the thumb.
Will
Thumb
give
is
the
going
force.
in the upward direction.
Upward
Upwards.
direction.
Yeah. So direction of the force will be upwards.
So in the second case also it will be upwards then. Because
no,
wait. I got it. It's different
actually
direction. Because current is in different direction.
Yeah. This wire is tilted like this. So accordingly
you
have to see.
Yeah, sorry. It's towards the left.
Like this?
Yeah, it's
right.
Yeah, like that. It's towards the left.
See, here the magnetic field is inwards. Okay?
Yes, sir.
Not the inwards.
No, sir, outwards.
Sorry. The magnetic field is outwards, and the current is going in this direction.
Yeah.
And outwards means something is going towards you. So what you will do? You will point your fingers along the direction of the current and curl your fingers towards you like this. So this thumb will give the direction in this direction.
It's a left.
So this will be the force.
Yes, sir.
And this force is perpendicular to the length of the wire. Okay, now we will drive a relation. Just note down this. Okay. We have only you have to go at 8:30, huh?
Yes.
No, not 8:30. According to me, I am telling you. I mean, after the 9 minutes.
Yeah, according to you, sir. Yeah.
You are where right now?
I'm in Saudi Arabia, sir.
You are in Saudi Arabia. And what is the time there?
5:51.
5:51. Here is 8:21. Okay.
Yeah, it's 2.5 hours difference. Done, sir.
Okay. So next derivation is very, very easy. I will require this formula. What is the formula for a force on a current carrying wire in the magnetic field? That formula will be required. And this right hand rule I have told you, this will be required. We will easily calculate. And in your exam also this derivation has appeared.
Yeah. Sir,
So
I know I can do this. Yeah, I have done this. It's the final answer will be mu naught I1 I2 divided by 2 pi d is equal to mu naught I1 I2 divided by 2 pi d.
So you see here are two conductors. This is one conductor, and this conductor is long conductor, infinitely long. And this is another conductor. This conductor is also infinitely long, and A is the distance between the two conductors. So you can say here in this conductor the current is I1. In this conductor the current is I2.
And the magnetic field for conductor 1 is out inwards.
Let's see. This current, due to current in this wire, there will be some magnetic field generated around this wire.
Yes, sir.
And this wire is in the magnetic field of this wire. And this wire 2, is in the magnetic field of this wire, and this wire 1 is in the magnetic field produced by this wire. So I can say that wire 2 will be in magnetic field produced by, because the current carrying wire, this is the current carrying wire, and this current carrying wire is producing the magnetic field, and this wire is in the magnetic field produced by this wire. So that magnetic field, suppose V1 is the magnetic field produced by the wire 1. So magnetic field due to wire 1, wire 1 is, suppose that is V1.
Yes, sir.
So can you tell me what will be the magnetic field at this point, at a distance A from this wire, for the infinitely long wire? What is the formula? V1 is equal to mu 0 divided by
4 pi
2I1 divided by A.
Yes.
So this is your magnetic field. So this V1 is the magnetic field on this wire. Means due to this wire at a distance A from the wire, the magnetic field will be this. So this wire will be in the magnetic field V1. So this wire V2 is in the magnetic field V1. So now you can say, now focus on this wire. This wire is in the magnetic field V1, and this wire also have the current. So means this wire 2 will experience the magnetic force. Okay. This wire 2 will experience the magnetic force. So you can write here due to V1. The conductor 2 will experience a magnetic force. Magnetic force. And that magnetic force is given by the formula. What is the formula? F is equal to current I in the wire, length of the wire, magnetic field, and sine theta. Theta is the angle between the length of the wire and the magnetic field. Okay. Now I am just calculating the force on the wire 2. Force on the wire 2 is equal to current in the wire 2 is I2.
Yes, sir.
Length of the wire is suppose L2.
Yes.
Magnetic field is V1.
B1.
Why we,
and then sine theta.
Yeah.
Sir, because it's on 2 due to 1.
Good. So you can write this force on the wire 2 due to the wire 1. And this is sine theta here. Now,
yes, sir.
How we will calculate the sine theta? See, sine theta, theta is the angle between the length of the wire and the magnetic field.
Yes,
so
sir.
See here, we have to find the direction of this magnetic field. You will apply the right hand rule and point your thumb in the direction of the current for this wire number first. Point your finger in the direction of the current and point your thumb in the direction of the current. Okay, and point your fingers towards the point where you want to find the magnetic field and curl like this. So
yes,
here
sir.
you will get the direction of the magnetic field due to this I1 will be inwards. Inwards means the angle between this length of the wire and the magnetic field will be 90 degree. So theta will be 90 degree. Okay. So you will write sine 90 and sine 90 is equal to 1.
1. So like it's just nothing.
Sine 90. So now you will put the value. I2 is there. L2 is there. And magnetic field is given by mu 0 divided by 4 pi.
4 pi.
2 I1 by A. Okay. And sine 90 is 1. So finally you will get this F21 by L2 is equal to mu 0 divided by
4 pi
2 I1 into I2 divided by A. So basically we have calculated the force per unit length of the wire 2.
Yes,
Okay?
sir.
Force per unit length of the wire 2, when you will calculate force on the wire 1 due to wire 2 and length 1, force on the wire 1 per unit length, this
Yeah.
result will also be same.
Same, yeah, it will be
Yeah.
F21, it will be equal to F12.
Yeah. 2I1 I2.
2I1 I2 divided by A.
So this formula you can get. And just note down this.
Yes, sir. So can I scroll down?
So F21 is the force on wire 2 due to 1. Due to wire 1. Simple. And F12 means force on wire 1 due to wire 2. So if you have the two conductors,
Yes, sir.
okay, then and in those conductors, if you have current, then those conductors, there will be some force on those conductors due to each other. Okay, due to each conductor, means due to the conductor 1, there will be some force on the conductor 2, and due to the conductor 2, there will be some force on the conductor 1.
Yes, sir.
And this is happening because of the magnetic field produced by the conductor. Because the current carrying wire produces the magnetic field, and the conductors are in the magnetic field produced by the other conductor. So that is
Yes.
why there is some force on the conductor.
Done, sir. I wrote that, sir. Done.
So now direction. For the direction, we will use right hand rule. Okay?
Yeah.
So for this conductor, what you will do?
We'll put the
Your
4 fingers in the direction of the current
and
and
what is
then
the
curl
direction?
it
And the direction of the magnetic field is towards you,
inwards.
means inwards.
Yeah.
So
Inwards.
you will do like this. Your
Yeah.
finger should be in the direction of the current, and you will
Yeah.
curl like this. So you will get the direction like this.
Yeah. Minus I have.
So when you just actually, this is the not here. You have to curl like this because this direction is inwards.
Inwards.
Okay, inwards means away from me. So I will do like this.
Yeah.
Okay, this is the direction of the current, and this is the direction of the magnetic field.
Inwards,
So
away
in this
from you.
direction, I will get the force.
Yeah.
So the direction of the force will be like this. So on this conductor, the force F21 will be like this, and on this conductor, the force will be like this.
Yes, sir.
Means both the conductor will attract each other if there is the same direction of current in both the conductors. Okay, now you also you can also calculate the direction of the force with respect to this conductor. For
Yes,
that,
sir.
you should know what is the magnetic field due to this conductor. So due to this conductor, so point your thumb in the direction of the current and curl. So you will get the direction like this towards you. So here the magnetic field will be outwards.
Oh, yes,
Magnetic
sir.
field will be
Outwards.
outwards. Okay. And you will now apply again the right hand rule. Point your for the force, you will apply again the right rule. Point your fingers along the direction of the current and curl like this. Okay. So you will get the
Yes, sir.
direction of the force in this direction. This is
Towards
F12.
me. Towards me.
Yeah.
Yes, sir.
You will curl this time towards you because this
Yes, sir.
direction
Towards me because
represent the
it's out.